Welcome to Homework Lib.
Section 14, problem 38. We are given a reaction, and there are 4 experiments corresponding to this reaction. So at part A, they're asking us to find the rate law for this reaction. So the rate is supposed to be something like this. K is 208 minus 8, well, minus 2. I minus, and this is supposed to be our rate, but we don't know what the order is for this rate. So to be able to find the m and n, you need to pick 2 of the experiments and compare them with each other. So I'd first like to pick 1 and 2 because over here the i's do not change. So if I pick 1 and 2, what we're going to get is these k's are going to cancel each other, and we're going to have 27 of S2O8 to the power of m, and 18 S2O8 to the power of m. Now, since these two are the same, I'm not even writing all those. And this is going to be 3.9 times 10 to the power of 6, but they're going to cancel each other too. Divide by 2.6. So these cancel each other. What we're going to get is, in the common power of m parentheses, we have 27 over 18, which is, if we divide all those by 9, going to be 3 over 2 to the power of m equals 2. Over here, if we do the same, this is going to be 3 over 2. The common denominator would be 13. So this is going to be 3, and this is going to be 2. So in this case, m equals to 1. So we can just write 1 over here. And we're going to do the same thing for finding the n. So which 2 can we pick? I'm going to pick these 2, since 18 to 36 is going to be twice as much. So we can find this ratio. And once we do that, what we're going to have is 2 to the power of m, which is 1, and 0.054 divided by 0.036 is going to be equal to 7.8 divided by 2.6. Now, this is going to cancel to 3, and this is going to cancel to 3 over 2. So there's a 2 over here, they're going to cancel, and n is going to be equal to 1, 2. Okay, at B, they're asking what's the average value for the rate constant of the disappearance. Let's say this was A. And at B, what we can do is we're just going to write the numbers into this rate law over here, all these numbers. For experiment 1, S208 is going to be 0.018, I is going to be 0.036, and the initial rate is going to be, this whole guy is going to be equal to, for the experiment 1, 2.6 times 10 to the power of negative 6. So we're going to get a k value. We're going to do that for all 4. And once we add all of them up and divide by 4 to find the average value, we are going to end up with 0.003981. At part C, they're asking us how is the rate of disappearance of S2O8 is related to disappearance of iodine. So we need to recall one thing. That's the very first thing that we learned. There's a hidden one behind S2O8. So how we can write this is going to be delta of concentration of S2O8, and this is going to be divided by delta T. That's for time. You can write it seconds too instead. And we flip this hidden 1 is still going to be 1. And we flip this 3 to 1/3 delta of iodine divided by delta T. So this is going to be the rate of disappearance of S2O8, and this is going to be the rate of disappearance of I. Well, they're negative signs, but they're not important since they're going to cancel each other. So as you can see, the rate of disappearance of iodine is 3 times more than the rate of disappearance of S2O8. At part D, they're asking us what is the rate of disappearance of iodine. Let's solve the D here. The rate of disappearance of iodine when S2O8 is this much and I is this much. So again, we're just going to write the average value of K, which is this guy, into our equation and write this number into S2O8, and we're going to write this number into I, and we're going to get the number 4.97 times 10 to the power of -6. Now this is the rate, but as you can see over here, the rate is not going to be this number. It's going to be 3 times more for iodine. So we're just going to simply multiply this by 3. And I'm rounding this entire value up. Please do not round when you solve this question. If I round this to 5, what we're going to get is 1.5 times 10 to the power of -5.